Okay, good evening. It is day 31. Um, Today I want to build out the CLI command line interface application that I was talking about the other day. I was looking into it a little bit, not as much as I should have. So that's going to be a majority of the beginning of this video. Is just looking into like actually how do I make a command line interface? Like at first I just wanted to be like I can type something in and something will just print. Um, like it'll show us that we're in the tool, and then I can like write some functions that I can like say something and it'll like print something back, something basic. And then actually what I want to do, if I can get that done today, if that takes me, I don't know. We'll see how long that takes me to do. Um, if it doesn't take a long time. See, the only thing is, like I said, I kind of want to actually wrap one of my applications um, in, like make my application into a Docker image and just like understand like how Docker is actually working. Um, because it's gonna make this a lot easier to do. So I think we might do. I talked about this yesterday actually. I want to take the code visualization app, just kind of polish it a little bit, right? Make it the actual prompts that we're giving a little more refined, so the responses are better. Make sure like the actual visuals on the app look nice. And then, I mean, again, there's still a lot that needs to be done, but uh, but for now, I can just leave it as I can just leave it as like something that's like unfinished, and then I'll do my Docker stuff to containerize it all. Make an image, and then that way I can like I understand Docker to a certain degree, and so then we can actually move on with this and start doing the Docker stuff. Because actually, what would be nice is if I do the Docker stuff for the app, and then as I'm working on the CLI stuff, I also work on the app and making it better. And then when I have to redo the Docker configuration for whatever I've changed or whatever new libraries I'm using, whatever it is, that way I can test out that on that application and see if it does what I'm trying to get it to do. Um, so yeah, so that's the plan. I'm assuming half this video will be just looking into how I can make a command line interface, and then either I'm going to do a leak code at the end of this, or I'll just or I'll work on code visualization app and trying to set up and trying to refine that. And then tomorrow's also going to be a pretty shit day, I'm pretty sure, because I need to get all my stuff packed for the move on Wednesday. And then on Wednesday in the morning, I don't have any time, and I'm going to watch the football game, the Texas Longhorns, and I think there's actually three games tomorrow, Wednesday, I'm pretty sure. So it's probably gonna be another shit video that day. But then it should be good. So yeah. Anyways, um, this is what I was looking at. So like we were talking about yesterday, the tool um is so I you can run something. So if you were to type in a keyword, which would be my tool, and then on the root directory or in the root directory, right, of your application, you would run the tool, and then it would like I want it to like print because I remember there was a server for my school that you'd like SSH into, and I really liked when you'd SSH into it, it'd like give like information and it would like print stuff in like a cool like 1 second. Yeah, sorry. It would print stuff into like this cool and just like in like an ASCII way, I guess, to just display some information. So I want it to do that, and then for now, what I'll do is I'll do like, oh, ask questions, and I'll just have it regurgitate the questions, like save it. So I won't do any of this. I think the biggest part of this is going to be working with the actual Docker side of things. So I'm only going to focus on the CLI part of this right now, and then we'll work on Docker after I've made the code visualization app into a Docker image and ran it. So, okay, click. Oh, it's actually kind of sick. Okay. Okay, so for now, we just want it as a Python file, right? So we can just say make directory echo. I guess I can do. What is this doing? CLI dot py. Um. Okay. Create a parser object. Add parser object. Okay, so we import this, create argument password object, and also provide a description of our program, an addition program. Fill up our parser object with information by adding arguments. Oh, and a help. Okay, let me just look at this actually. Well, actually, I also need to do a little npm pip install arg parse intol. Cool. Okay. So now I can save this. And what I can do CLI.py. Sorry. Python CLI.py 1 2. Okay. Cool. Yeah, so parser is equal to an argument parser, gives a description. And so what was the -8 is help. Usage CLI up IH blah 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 an addition program. I see. So it says so we add the argument add args is equal to parser. I see. I kind of see. The number of command line arguments that should be consumed specifying it means it can be any number of arguments. Okay. Oh, I see. N arguments. Star is infinite. Type of argument that should be converted. It is string by default. And argument 5 is a description of what it does. Okay. Mm. Oh, so we have a validate file, which we just call it. So we have a read, a show, a delete, a copy, and a rename. Main creates parser object defining all the arguments past these, and then if args.read, then we call that function. Okay, so what? Does this only work on text files? Okay, so dash. So let's read off. What's a text file I have? Wait. Oh wait, I can just make one. Echo just a test.txt. Else if not. This is not Python? What? Oh, that is true that is just, it's an elif. Where even was that? Does not match any. What are you talking about? Let me check those DMs real quick. Okay, I'm back. Sorry about that. Where were we? Um, okay, whatever. So what this was recommending to do was banner click. No. This was for the package. Here it wanted to do. Why does it not have? Okay, sure. Install all these. Bop bop bop. Regex. Wait, it's actually installed. Uh, whatever. ASCII art. Root command. Let's just look at this shit. So if I go here and I just run Python CLI.py, right? No module inquire. Is that not? What about now? Oh, help. So what is it wanting here? Okay. I don't care about you at all. Okay. No such option. Oh, wasn't it like in it? Nice. Beautiful. Okay. Okay, so Docker banner is equal to just this. Click group. It says this, but if I pass through CLI, it doesn't like recognize it as like a function or anything. So init does this, and then it does question, blah, 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 blah. You get this, and it will store this. So actually, what I could probably also do, I'd assume answers is equal to this. I want to print answers. Click.echo answers. Okay, base image. Okay, nice. So we'll have our image, what directory that we're in, the port that we want to use, and that's actually great questions. That's exactly what I was thinking. Okay, beautiful. Okay, so you can put anything though, right? You can be like, what? Sorry, my father came in. This would be actually I should take your current directory that you called this from. But anyways, if I just do code, uh, Docker tool main, right? Port 1000. Okay, very nice, very nice. Yeah. What if I did like, this is supposed to be like a U, right? Oh, shit. Shit. Shouldn't this have like a that? Like a that? Actually, that was kind of good. Wait, how did it get it there? Oh, oh. There. See, I'm good at this ASCII stuff. and then the U. Well, actually, fuck. How do I like uh whatever this is? I'll take. Oh wait, no. Oh, it's like an underscore up there. I see. But this needs to go back. Right, and then up here. Bam. Bam. That. This would be a lot better if I just do that, right? Okay. T. T is gonna be like this. Or sorry. Bam. Little stumpy, little stumpy. That's fine. Oh no, that was fine, right? Bam. And then I just need the O, which is right here, which I can just take again. I guess I'll have to copy it. Yeah, not sure this is the best use of my time, but like, fuck it, right? Right? Bro, it looks like that's like wider, no? No, I don't think so. But then I can yank that. Uh, I feel like I should. Uh, Bam. Isn't it beautiful? Spent way too much time on that. Okay. Anyways, so that is that. So I mean that's a command line interface. Um, one thing I wanted to do was default is going to be current path. So I need to import OS is already there. So how so I want to do this and then I can do file path. Fuck off. Okay. You go to path. Okay. File. But like what file do I want? I want it to be like I mean CLI.py, right? But I'm pretty sure uh os.path. What? Okay. Actually, I wonder if this even fucking works. I need to change this to back to just a string for now. Okay, beautiful. So I can just say um and then can I just say default equals current directory? Amazing. Okay. How long ago was this post, by the way, for that not to be like a top answer? Oh, asked 14 years ago. Beautiful. Beautiful. Okay. So up next is going to be what? Oh, I wonder, auto word ASCII. Yeah, probably should have done that to start. Okay, beautiful. Um, What the fuck? Oh, wait, this is sick. 3D. Oh, I love me some 3D ASCII. I won't lie. This one's definitely the best. Oh, no, 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 no. I wanted. Oh, never mind. Um, ba-ba-bum. Okay, this is just getting worse and worse. Okay, whatever, whatever. That's not what I should be spending time on. So I guess I mean this is what I just wanted to get to today, right? Oh, I still didn't understand. I see. So if I go back to the bigger one, which is this, we have our CLI. Actually, huh. Interesting. Whatever. Um, all right, up next, I wanted to look at sorry. Wait, really? Why am I saying CS? What the fuck? Okay. Ba-da-bum. 27, 27, 26, 27. Just one. Okay. That's actually it's actually quite nice. I mean, obviously the line shouldn't be going through the nodes, but um that is quite nice. Okay. So the whole idea was I wanted to clean this up a little bit. Now, I did have the thought I had the thought of okay, in the future, I want to make this app so you have a history on this side, right? So you can go back and you can look at previous gifts or, creations. Yeah, I guess I'll just leave it. I was gonna say like maybe I want to do like a hovering text enter thing that you hit. Um, but I'm gonna eat dinner as well, so I'm back. I was just thinking about it. I'm actually really impressed with this generation. This was really good. Not only did it do really well on the actual generation, if we look at the prompt, um, should be here. Maybe it's not. Never mind. Um, okay. Well, what I did have at one point was to make sure that it rendered at the top of the scene, but I don't think it's doing that. I think this is an older version of this. But anyways, it works. So the whole kind of point now was so I was thinking about like cleaning up. Um, but like what is there to even clean up? I mean, there's like shit I want to add. I wonder, um, what do I have this as a text area in oh, wrong thing. Nah. So how to make mm, HTML canvas. ChatGPT is better at this. Hmm. I mean, I'll look at this, but I don't think this is correct just by looking at it. Um, I think it's going to be a lot smaller than what I want it to be. Yeah, that is cool though. That is cool. But um, into what you visual. Okay, so query selector request.send, same thing. Okay. Add drawing functionality. Canvas, the still container query selector, drawing canvas. Resize canvas to fit right side container is drawing equals false. Enable drawing by setting pointer events to auto. Listen for drawing. If mouse down equals true, begin path and move to whatever the coordinates are. Mouse move. Wait, what is this then? On mouse down, it does this, but then on mouse move, if is drawing, so is drawing equals true. Set line color, set the line width. Line 2 dot stroke. Okay. Mouse up, close the path. Is drawing is false. Mouse leave false, close path. Looks good to me. Well, drawing canvas is there, but it's not really doing anything. Come on. What was happening before? Yeah, no, it was the exact same thing. Or the key change. Add a utility function, get mouse position to calculate. Okay. Nothing. I wonder though if what if it's just like a Z index thing? You know? No. This is all picky stuff, to be honest. Give it one more shot, and then I'm just kind of done for this for right now, because this isn't the point of today's video. The point is Docker work. In there we go. Oh, perfect. So what changed? Resize canvas on window load. And so does this work on... Ba-dum, bum, ba-dum, ba-dum, bum, bum. We just have to wait a while. No idea why this happens. Give me Oh, there's actually a video uploaded by a guy I liked recently. Fuck, what is he? This motherfucker.
Hey, my name is Forrest. Welcome back. Let's make a Docker container together. Let's just run one from Docker Hub, the
Did this render yet? No.
base Ubuntu image. And there it created a container. Let's see if it's running. Sure enough.
You want to see me do it again?
This time, let's run our custom image for our application, which as you can see is now running on localhost 8080. This is our custom application running on these two containers, a database container and our app server container, creating our front end and our back end. Easy stuff. We're going to talk about all of this today. We'll go over why devs use Docker, what it is and what it does, of course Docker Compose, and how Docker fits in modern development in various different ways, including a handful of new Docker tools. With that portion of today's video being sponsored by Docker Scout and Docker Build Cloud. So by Docker, but those two specific tools. Let's start with why devs use Docker. Well, I'm sure you've heard it before. It's because it containerizes your entire development environment. But what does that mean? Well, think of containers like perfectly packaged applications. Everything your code needs to run, the runtime, the dependencies, the configuration, it's all bundled together in a reproducible way. That means when you're sharing a project, you're not just sharing the code, because that would require, if you're sharing it with me to install Java and all that entails, and various dependencies, and so on and so forth. You are sharing the code, but you're also sharing the environment it runs in. This used to be done via virtual machines, or VMs. They create entire virtual computers, including the hardware and the operating system. Docker does things differently, though.
So
Instead
good.
of virtualizing,
I want to add, now I have to add tools, because I need to add changing your color, clearing this, in which I will add that, like statically at like this top right position. But I'll do that at a different video because today is about Docker.
Virtualizing everything. It only virtualizes the operating system. Just that layer, no hardware requirements and things of that nature. It makes it less bulky and it makes it faster. This means all Docker containers share the same OS kernel, which is why they're so much lighter and faster than VMs. And that's really the main takeaway here. Lighter and faster. I mean, that's kind of what we want, right? Now let's take a look at this example app we'll use to really understand Docker. It's from the official Docker samples, github.com/Docker samples. And you don't really need to worry too much about the specifics. What's important is that it's got a pretty common setup. It has React for the front end, Java for the back end, and a database.
It's
and a
not
connection
running.
to payment gateway. You've probably worked with something similar before. If not, well, pretend
No.
it's some sort of Node.js with Redis and PostgreSQL database or whatever lane you're in, pretend it's that. And just to note, I'm going to be creating my own fork of this or my own repository of this because it was archived in 2021 and hasn't been updated in actually 6 years. So I had to make a few changes to the Docker file and Docker Compose files. I'm also going to be removing the dev file here and the dev file here just to simplify things. So if you want to follow along or use this example for yourself, use the one on my GitHub account. I'll link it down below, not the one on the Docker samples GitHub. I'm just going to clone
I probably should do this, right?
this here and then
Give me this. Give me. Didn't want to do that. Restore. Okay. CD into OneDrive. Desktop code. And git clone that.
look at the app itself, ls, and you can see how it's structured. So we have a Docker Compose right here. We have Docker Compose dev for, well, dev stuff. But within app, there should be a Docker file, as you can see right here. And this is that Docker.
Yeah, so if we do, I mean, I can just neovim, give me that Docker file, app Docker file.
This you can think of as instructions for setting up your dev environment. And what we have.
And so what is this doing? From latest node as a storefront, work directory, it's a React app, copy React app, run npm install, run build, which I think is just for a React thing. This is JDK Alpine. That was SDK.
Here is what is called a multi-stage build, and very specifically a 3-stage build process to create our complete application. The first stage handles the front end, the second stage handles the back end compilation and all that, and then the final stage brings it all together. So if we want to run through this we're utilizing Node.js to build our React front end, and you can kind of see what's going on here in npm install and npm run build. Then in the second stage we use Maven to build our Java backend. And when I say we, again, this is a sample. I didn't create it, but I'm going to say we as if I did. But just to be very clear, I didn't. So we're very smart about this. Okay. Any of these 7 contributors right here, they were smart about it because what they're doing here is copying the XML file and then running to resolve dependencies first and then copying the rest of the project and building that, which is the actual application. And then in this third stage, we set up our runtime environment with a very lightweight image of Java Alpine. This is adding a user, non-root by the way. This is copying the front-end build, and this is copying the back-end build. And this is running the back-end build. And because we're using a multi-stage build in the way it's structured, front end, back end, bringing it all together, it keeps our final image, what it creates, nice and slim, since it only contains what we need to run the actual application. Because again, it is just copying what we need from up here. Anyway, I just want to drill that into your heads because this is where it begins. This creates the image. You can think of the Docker file as the recipe, right? You have a recipe to make a meal, but the image is the actual meal. And an image is just a snapshot of everything we need to run our app. However, isn't Alpine deprecated, so we need to do open JDK, 8 JDK Alpine. Just
Does he do this in, yeah.
to ensure it works. So Docker build -t at
Okay. So let's go back into here and do Docker build. What do you think T stands for?
c-shop period.
At C shop.
The period tells Docker to look for the Docker file in this directory. Enter.
Failed to read Docker file open, no such file or directory. Docker build at C dash shop. Oh, you know what it might be? It might be, I need to be in here. There's gonna be a CD into OneDrive desktop code. This. Oh, CD app. So I probably can do it in that other one. Build T at C dash shop period. I wasn't an app directory. It probably would have worked in the other one. So it's building this and this.
Docker to look for the Docker file in this directory. Enter. And as you can see, it does take it a bit of time to build. At the end, we're going to be talking about Docker build cloud, which will drastically decrease the amount of time it takes to build. And as you can see, that command is running through our recipe. You see run add user, you see run npm install, run maven, copy the XML file, and so on and so forth. So 132 seconds, so that's 2 minutes and 12 seconds it took to build our image. Keep that in mind, because later in this video, we're going to run build cloud, and we're going to see just how much faster it is. Timestamps are below, by the way, so you can jump to it now if you want. Just make sure you come back, because we're not done. Image is not the final part of this, but you can see how Docker read our Docker file and ran it step by step to build our image. And after all of this was done, what we can do is run Docker images, and now we have an image that'll run anywhere. Your machine, my machine, in the cloud, wherever. Sorry, I hit the mic. That happens from time to time. I got to figure out a new setup, but wherever. And as you can see, at C Shop, latest image ID created 3 minutes ago, and size is 300 megabytes.
What was it? Docker images? Oh my god. SRC frontend MySQL Python app. Wait, I've done this quite a bit. Wait, 3 years ago, Docker desktop.
Now what we do with
I installed Docker 3 years ago on this PC. Wow.
images is we use them to create our container.
Actually, I think.
So
All right.
Docker file creates the image, which creates the container. Now let's bring our image to life, if you will, with Docker run -p 8080 colon 8080 at C shop.
So this is the steps that I'm going to be. So okay. So obviously this will be like if they selected yes on my questions from earlier, then this is what it would do. They already selected their port, so this would go in as port.
Since that is, of course, the name of the image, because we could have multiple images in here. We want to specify which one we want to run. And what this part right here, -p 8080 colon 8080 is saying, it's just telling Docker, hey, When somebody hits port 8080 on the machine, direct them, send the traffic to 8080 in the container. And here we go, firewall.
Bop. Oh. Cute.
Yes, it's okay, it's okay. And as you can see, it is running Spring Boot, which is what we're using with Java, Spring. But as you can see, it's not running. We're facing an issue because it's trying to connect to a PostgreSQL database called database. But we haven't set up the database container just yet to link it with our application. And we would actually create the database container just like we created the app container. We used this Docker file to create an image and then the image to create a container. Well, this database directory also has its own Docker file so that we can use this Docker file to create the database image to create the database container. Because like in this app or in the real world, you'll often find you have multiple services that need to run together. This is where Docker Compose comes in, which you previously saw in our project's home directory right here. The thing is, without having the Docker Compose, what we would have to do is with the database image that we created, we would have to run it to create the database container, and then we'd have to create the app container, and then somehow we'd have to make them talk to each other instead of the right networking and all of that. It can get a bit messy. However, instead of running each container separately and trying to wire them up manually, thanks to Docker Compose, as we see right here, we can do all of this in one file. Check this out. So we have our services. Our services have our database here, we have our app server here, and then, well, technically, what we used to have was our reverse proxy, our database, our app server, our payment gateway, but I had to redo it all, and I wanted to just make it very simple and make it our dev environment. We won't use reverse proxy or payment gateway in dev anyway, so we're just running with database and app server. These are running their own containers, and Docker Compose is tying them together. Or I should say that more technically. It handles setting up a network for them to communicate, the container startup order. As you can see, the database needs to start up before the app server, like I just said, and then manages them as a group. That's actually what this depends on is saying right here. It says, hey, make sure the database is running before starting the app. Pretty cool. So now instead of, running each container one by one and going from there, all we have to do, and I'm just going to hop back in here because it's shorter and you can see it a little bit better. All I'm going to do is Docker Compose up. That's it. Just
Docker Compose up. That's it.
watch how Docker orchestrates everything with our Docker Compose. It starts the database, waits for it to be ready, then fires up our app, and all the networking between containers is handled automatically. And it is started etc app in 11.885 seconds, JVM running for 12.628. And just like that, our etc shop is running on localhost 8080. I know you can't see that up there.
Wow. It's pretty sick. That's pretty fucking sick. Won't lie.
There, it's marked off, but that's where it's running, which you already knew because of this. Earlier, I had Docker.
So is the back end on what was it? 5050? No, it was 5005, right? Nope. No, it was. Weird.
Run, and then the port tag mapping our 8080 on our machine to our 8080 in our container. And that's being done right here with
I mean, it has to
our
be
app
this.
server. Yeah, you can't really see that. There we go. Oh, crap. We're still using dockerfile.dev. Luckily, they're the same. The Dockerfile and Dockerfile.
Give me. Where am I in right now? I'm not in app, right? So I want. Compose. Yeah. So this was the database. Database is running on 5432. Okay, weird. Usually you can go to the database file and it'll like at least print something. Apologies. I'm dumb, I guess. Okay. That's cool though. So the only question I have is so does this mean um I can stop this, right? And delete this, and this will still be fine, correct? Because this was, yeah, and this is fine, correct? Well, link of startup packet. It should be fine. But anyways, uh, okay, yeah. So it just doesn't show. Anyways, so this is, what is this? Okay. I mean, cool. So I think the whole thing is, that's really weird though. Why was it that when we ran the application, okay, can I stopped and stopped. Here, let me delete everything. Everything. Delete forever. Delete forever. Okay. So if I literally say Docker Compose up right now, I deleted everything. Will this even work? Obviously, wait. Obviously, this is down. This is down. Never mind. It's okay. Okay, wait. I did this wrong because I want to make sure that I understand this. So let's stop both containers. And delete you guys forever. Okay, so now if I go back here and I refresh. So we go back to that, which was running. Okay, that's kind of funny that I'm running this on 8080. That's kind of funny. Anyways, but that's crazy. So like I have no images, no containers, right? Ooh. I just want to make sure there's nothing. Because this is crazy how fast this is spinning up. Because beforehand it took 2 minutes to just run and get the image of the front end. And that spun up. Wow. Wow. Okay. That's sick. All right. So the hardest part of this here, let's finish the video.
Dev, but let me just change that. Now this is really cool. It is super nice
1 second. I'm back.
to use. The only thing is that building containers can be slow, especially with big applications. And I showed you how long it took to build our container earlier because we have Java compilation and npm installs and it could take a while. Let's actually
Why I'm still confused as to why earlier when we made that build, right? Why it took so long, but this time when I'm just doing a compose, it was so quick.
let's actually rerun it. I'm also going to
There has to be something that was created that I'm not deleting that is just referencing So I'll figure that out when I do another Docker, thing. But see.
Clear the cache. Remove all dangling build cache. Are you sure you want to continue? Yes. That's a lot. 3.766 gigabytes. Everything is clear. So what I'm going to do now is compare the build times of the app Docker file without build cloud right now and then with build cloud. So time docker build period. Let's do it. And while it's building, we're already about 70 seconds in. I do want to mention one thing. In order to have Docker working, I am in WSL Ubuntu, as you can see down here. I had to install Docker Desktop on Windows, enable WSL so that it can work, and then once I log out of my computer and then back in, and I made sure I am logged into Docker Desktop as well, then and only then will I be able to go do Docker build like I did before. That's the way you get Docker within WSL2. And if you're using Windows, you need to be using WSL2 for sure. Whew, okay, 2 minutes and 32 and a half seconds. 152.2 seconds. That's 2 minutes 32, 2 minutes 32. Yeah, wow. All right, so I'm going to keep that there. I'm going to create another terminal just so we don't forget. And you're able to enable build cloud within Docker Desktop. Obviously, it's built in, but you can also do it with.
Oh, I wanted to go back and look at. We're at 12:16.
And it could take a while. Let's actually rerun it. I'm also going to
Docker builder. So what? I can do Docker builder prune. Yeah.
clear the cache. Remove all dangling build cache. Are you
So what does this do to this? That's still there. Images are still here, right? In use. Okay. By the way, I don't need any of this shit, bro. Just delete it. I don't care. Weird.
sure you want to continue? Yes. That's a lot. 3.766 gigabytes. Everything is clear. So what I'm going to do now is compare the build times of the app Docker file without need to be using WSL2 for sure. Terminal just so we don't forget. And you're able to enable build cloud within Docker Desktop. Obviously it's built in, but you can also do it within. I know you can't
I'm back,
see
sorry.
that I'm in the way. We're going to call this Cloud Builder. And then just staking it out.
I mean, this is
file
just a cloud thing.
locally. What I cleared out before and what I just built over here is all stored locally, whereas this obviously is stored in the cloud. So I just need to make sure I'm all clear here. I am, because I haven't built it yet with cloud, that is. So now I'm going to build it with cloud here. While that's building, just to clarify, this is 2 minutes and 32 seconds long of a build. So this just needs to come in under that and it's faster. And there we have it, 65 seconds on.
Okay, that wasn't crazy. I thought it was gonna be some crazy shit. That's still
24 out of
Oh, okay. Nah, never mind.
24, however, whereas over here was 27 out of 27. The few differences are that build cloud will combine some steps, like the off.
Okay, I get the general idea here. There's still some stuff I need to go over on my own. This stuff's really cool, by the way. This I need to work on. I'm gonna even work on it like offline tonight, like as I'm doing stuff in between, like whatever. Yeah. So the plan is up next. Plan. I need to wrap up a few things with the Code Visualizer app, and then I'm going to make a Docker image out of it and make sure it can run. Okay. I wanted to see if I could get this running on a serverless architecture. So here, wait. Yeah. I wanted to see if I get this running on a serverless architecture. So we'll see about that. Otherwise, after I do that, we can work on the CLI thing. Obviously, it's going to be tough to figure out all the edge cases of like building compose files, building Docker files, you know, figuring out. I mean, at the end of the day, right? I can ask as many questions as I want to the user. This would be insane if it was fully automatic. So, I mean, it's just like when you create like a React application, right? You put in like the name, the description, maybe like a version of like Node or something. I don't think you do that. But it's just it asks like a series of questions and then it builds out the React app, right? This is the exact same thing. My Docker tool will ask a series of questions and then it'll run, it'll build the image, it will show you what is happening. I'll probably do some stuff where it actually, instead of like doing a vomit of like when I run this, right? You see like all the shit that it spits out at you. I think if there is an error, you print the error. If there's not an error, right, then you can and then it'll just have like a progress bar and then it'll be like built, right? Image built. And if you checked yes on automatically run, it'll run it and then it'll put the port and it'll be like you can go to this port and you can look at the image running, right? And so that's gonna be the whole idea of the tool. Um so so yeah. Um yeah. The only thing, so like if you sent over an image to someone, if you wanted to run the image, you could just do Docker desktop, or I'm sure if they're on like Linux, there's some command line thing. So I was gonna say, would it be useful to like have it to like just run images as well? I mean, obviously it's running images, but it's like this is the whole point is to build the image, and then if you want to, it can just automatically run it, but it shouldn't be. On Windows, you're gonna have Docker desktop, so and on Docker desktop, you can literally just click, go to containers, and you can hit start, and will boot up the application. So, okay, that is all I have for today. Pretty good. Clarified a lot on Docker, and got that CLI stuff working a little bit. Just like very basic prints to console and storing user answers to questions so we can use them later. So idea for tomorrow. Tomorrow I'm packing for move, so it won't be that long of a video. But the idea for tomorrow would be to clean up and make an image out of my own application, which is the code visualization application. Which right now there's no back end to, right? So we only have to make a single Docker file and image of that. And then if I have time after doing that, then we'll work on mapping out a game plan on what questions to ask and how we're going to go about turning someone's root directory into an image. So yeah. So I will end it here. And yeah, I will see you tomorrow for day 32. All right. Bye.